Hello, everybody, and we're back for another lesson as a part of Mr. Wheezy's weird and wacky, wild online learning. I don't know. I need to work on a name. Oh, let's be honest. It's not really wacky. It's not very wild, but I know I am weird. It's fine. We're moving on. So, today, proving parallelograms. Starting with kickoff there of what is consecutive angles. Consecutive angles are just angles that share a side. So as you go around the shape, the angles that would be on the same side that touch that same side. So think as you go around the angles in order, the one next to it would be a consecutive angle. So, starting to prove parallelograms. First off, we have our theorem 6.5, which says both pairs of opposite sides of a quadrilateral are congruent. This quadrilateral is a parallelogram. So, think backwards to what we did the last lesson. There we said if it's parallelogram, then we know opposite sides are going to be congruent. Here we're saying if they're congruent, then it's going to be a parallelogram. And we can prove those with a proof. So, in this case, we're going to be given xy and zy are going to be congruent as long as our wx and zy and xy and wz. So opposite sides congruent. So we're always starting with the given. Now in the notes, it's paragraph proof. I will try to make this into a 2-column. So we're going to start with that. The next step, we're going to draw xz, and that's going to be by construction. Because if all we know that opposite sides are congruent, we're going to draw in this diagonal. So what we can do with that then is, on 3 say, xz is congruent to xz, and this is going to be by reflexive. So knowing that, we can then say that triangle xwz is congruent to triangle. So if we went x, w to z, we'd do z, y to x, z, y, x. And that's going to be by side, side, side. That's our fourth step. So, proving this is our third set of sides, so we'd have side, 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 side. Knowing we have the triangles congruent, now we can start to say their parts. So this is going to be step 5. We're going to say that angle WXZ is going to be congruent to angle. So if we did WX to Z, we'd do YZX. And that's going to be by CPCTC. So if we mark that there and there, we would know, well, we have alternate interior angles. If we know those are congruent, which we do, then we can say that for 6, side WX is parallel to side YZ. And it's by, again, alternate interior angles, but it's the converse. I believe it's theorem 3.5. So that's where it's saying it's the opposite. If we know they're congruent, alternate interior angles, then we know the sides are parallel. So, for 7, we're going to do the proof. WX, YZ is a parallelogram. And that's going to be by definition. Something we could add in is after this we could really say then that so YXZ would be congruent YXZ to WZX, which is also CPCTC. to get that other set of sides. So then we would say that XY would be parallel to WZ. Technically, we should have that in there to kind of finish it off. So then it's official. There's your 2-column proof. If you look in the filled out notes, that's the paragraph proof version of it. But there we go. Then we have 2 theorems that we're not going to have to prove. I know, calm down. Don't jump for joy. Don't be too excited. Your parents are wondering why you're so excited for math. They'll think you're weird. Let's not have that happen, all right? So, theorem 6.6. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, kind of opposite of, I believe it was theorem 6.2 that we just did a couple lessons ago, where, if we know it's a parallelogram, then we know opposite angles are congruent. Here we're saying it the other way. It's kind of the converse of everything going on. And then 6.7, if the diagonals bisect each other, then we know the quadrilateral is a parallelogram. So, those have similar type proofs of what we just did, so we're not going to prove them in class, or at home in this case. And we're going to move on. Okay, I was kidding. I guess we're going to prove theorem 6.7. That was my bad. So, theorem 6.7 was that if we know they bisect, then we know that they're going to be congruent. So, this is another paragraph proof. I will try to put it into a 2-column, and we'll go from there. So, number 1 is our given here. So, step 2 then. Well, if we know they bisect each other at E, then we would know that BE is congruent to DE, and we would know that AE is congruent to CE. And that would be by definition. So, we know that if they bisect, it's cut into 2 congruent parts. So that's where we're going to roll with there by definition. We can also say then for 3 is that angle BEA would be congruent to angle. So if we did BEA DEC, so we're looking right here. Those are vertical angles. So now we have this side and this side. We have this side and this side, as well as the angles in between. So we can say that triangle BEA will be congruent to triangle DEC by side, angle, side. So we'd hit side, then an angle, then a side. Side, angle, side. Okay. Again, now that we know they're congruent, now we can say their parts are congruent. So we can say that side AB is going to be congruent to side CD. And that'll be by CPCTC. From there, we could also then say that our angles one and 2 there will also be congruent. So angle 1 would be congruent to angle 4, and angle 2 would be congruent to angle 3. We really do need all of that because if we're proving it's a parallelogram, we can't necessarily do it. At first, I was going to do it by having opposite sides be congruent. While this is true, to prove it's a parallelogram, by definition, opposite sides have to be parallel. So we have to show that they're parallel. So number 6, we now have opposite or alternate interior angles be congruent. So we can say that AB is going to be parallel to CD. We also know that BC is going to be parallel to dA. And again, that's by that theorem 3.5. So alternate interior angles. If we know they're congruent, then we know the sides are parallel. Theorem 3.5. So by 7 then, A, B, C, D is a parallelogram. And a reason? By definition. So, again, if you look in the notes will give you the paragraph proof version of this. I know you guys like the 2-column. This should be the 2-column that kind of summarizes that up and makes this work. Now on to another theorem that we don't have to prove. Theorem 6.8. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then we know it's going to be a parallelogram. So say L, M, and Pn, if we know those two sets of sides are congruent, and we also know that they are parallel, that's enough to say, I'm totally off the screen. Sorry, guys. So LM, Pn, if those are congruent and in their parallel, then that's enough to say it's a parallelogram. Because think about it, if these are parallel and they're also the same length, these then have to be parallel as well, because they're going to be the same distance apart. And continuing with that, we can still find what these values are. Because what do we know about the parallelogram? Well, we know it bisects the diagonals. So 2y minus 7 would then equal your y plus 2, and 3x would equal y. So this first one, only in y's. Let's solve that one first. We can find what y is, and then we'll plug it in to get what x is. So we would add the 7 across, because we want to get y's to the one side. We then subtract this y across. And so 2y minus y is a y. 2 and 7 make 9. If we put that in over here, we would divide by 3. So x then would equal 3. And for now, this is all we have to do. We don't have to find what those are. We're just finding where the values of for x, and technically we didn't need to find y, but we kind of did in order to find x. So we got both x and y. And lastly, I know this is kind of a short one. Can you prove the following quadrilaterals are parallelograms? Oh. On this first one here, we know that we have these two angles are congruent. We have these angles congruent. Those angles there are congruent. So in this case, 1 and 2 and 1 and 2 are both in these same corners. We have opposite angles that are congruent. So yes, we can. And that's going to be by theorem 6.6. Well, what's going to go on to here? Well, in order for it to be a parallelogram, now you can look at it and go, well, that kind of looks screwy. And yeah, it does look screwy. Because in order to be a parallelogram, opposite sides have to be not only parallel, but also be congruent. Opposite sides are not congruent. So you would say no, opposite sides not congruent. And that is it. So, questions, comments, concerns, please pan me, email me, send me a message on Google Classroom. Be more than happy to try and answer your question and explain it back out to you in another way. So that does make sense. Again, if there's something you didn't quite get, if you want to go back, rewatch a section of this video, pause the video so you can have more time to write stuff down, do that. And we'll talk to you guys later.